Hey guys, Mr. Barty was supposed to teach today, but, well, you'll see later. Anyway, today we'll be talking about superconductivity. Have you ever wondered how an MRI scan works? Well, MRIs are possible because of superconductors and their special properties. So what are superconductors? Superconductivity is defined as a phenomenon displayed by some materials when they are cooled below a certain temperature and have no resistance, so they no longer lose energy.
The reason for Berardi not teaching today is because he's stuck in the year 1911 with a Dutch physicist named Huyt Chamberlain Onnes, learning about the last greatest scientific theory, superconductivity. You see, superconductivity was first discovered when Onnes cooled the temperature of liquid helium, which causes resistance to disappear, like friction suddenly falling to zero. First fun fact about superconductivity is Onnes won a Nobel Prize in 1913 in physics for his research in the area, and now the passcode for the University of London is 1913, where Berardi once worked. 20 years later, German researchers Walter Meissner and Robert Ostfeld made a different discovery. Superconducting materials will repel a magnetic field so there can be no induction of currents. This is also known as the Meissner effect, which can be so strong that a magnet can actually be levitated over a superconductive material. This effect cannot be explained by conventional physics, so the theorists had to resort to quantum mechanics. The very first theoretical understanding on superconductivity was in 1957, thanks to the three American physicists John Bardeen, Leon Cooper, and John Schrieffer. Their theory was known as the BCS theory that explains superconductivity at temperatures close to absolute for elements in simple alloys. The second fun fact is these three men won the Nobel Prize in 1972 because their theory explains superconductivity as being due to an interaction between the electrons in the lattice of atoms in the material. This interaction causes the electrons to be weakly attracted to one another and forming Cooper pairs. The electrons are known as fermions, which means no two electrons can be in the same state, which is why matter doesn't always collapse down under gravity to form black holes. However, there is no such constraint on a pair of electrons, so all the superconducting electrons can fall into the same state. Another theoretical finding was made by Brian D. Josephson in 1962, who predicted that the electrical current would flow between two superconducting materials even when they are separated by a non-superconductor or insulator. This has been applied to electronic devices such as SQUID, an instrument capable of detecting even the weakest magnetic fields. In 1964, Bill Little of Stanford University gave the idea of organic, which is carbon-based, superconductors, which was later successfully synthesized in 1980 by a Danish researcher named Claus Bechard of the University of Copenhagen with three other French team members. The PF6 had to be cooled to 1.2 Kelvin and subjected to high pressure to be superconducting. In 1986, Alex Muller and George Bendors, researchers at the IBM Research Laboratory in Switzerland, created a brittle ceramic compound that could be superconductive at the highest temperature, then known as 30 Kelvin. Ceramics are insulators that do not conduct electricity, so researchers never considered them as possible high-temperature superconductor candidates. This discovery triggered activity in the field of superconductivity around the world. Now the current record for superconductivity is set at 138 Kelvin.
What is a superconductor in terms that we can understand? Superconductors are materials that conduct electricity with no resistance. This means that unlike the more familiar conductors, such as copper or steel, a superconductor can carry a current indefinitely without losing any energy. They also have several other very important properties, such as the fact that no magnetic field can exist within a superconductor. Superconductors already have drastically changed the world of medicine with the advent of MRI machines, which have meant a reduction in exploratory surgery. Power utilities, electronics companies, the military, transportation, and theoretical physics have all benefited strongly from the discovery of these materials.
Want to see a magic trick? Well, it's not really magic, it's levitation. Levitation occurs because superconductors repel each other when they are placed at opposite poles, creating a levitating object. A way to use levitation in everyday life and, not just to impress people with your magic tricks, are maglev trains. When cooled down to negative 450 degrees Fahrenheit, superconductors can be used to reach a speed of 375 miles per hour on a maglev train, which would allow one to travel from New York City to LA in just 7 hours. But as amazing as this sounds, it has sadly not been developed yet. But in the future, we could be floating to our next destination.
So if superconductors are so cool, then why don't we use them everywhere? Well, because the temperatures needed are so cold, the equipment you need is highly specialized and expensive, so it's not really practical for everyday use. So superconductors are really cool, just not realistic as of now. Oh, look, Mr. Berardi's back. Ask him if you have any questions still.